Today, we're going to review a couple of the homework problems from what I taught you yesterday, and then we got a lot to start diving into tonight. So let's start with looking at a couple of the inequalities from our homework. I'm going to pick some of the ones that I think were the tougher problems. So particularly number 19, 5 less than or equal to negative x. Now there's not a lot of things going on here, but we have to make sure that we're keeping track of everything that we do. All right, so the first thing is that I've got negatives, and I want to get rid of those negatives so that I have a positive x. But remember, when I multiply or divide by a negative with an inequality, I have to flip the sign. So this is going to give me negative 5 is greater than or equal to x. But that's kind of saying the sentence backwards. So I want to flip it so that I have x first. But the way that it's pointed toward or away from x doesn't change. So when I switch sides, the sign switches again. I have x is less than or equal to negative 5. Then I'm looking at the line, our number line, and it was negative 5's kind of off on the side over there. All right, so I want everything less than, which is meaning left of negative 5, and it does include negative 5. It is equal to negative 5. Right, so if you had something that looked like that on your homework, you're good to go. All right, in the next section, number 25, that's one I want to go over real quick. Yeah, this had n plus negative 18 greater than negative 5. Right, so we just got to make sure we do everything the right way. Right here, we're adding the negative. We're adding a negative number. That's the same as subtracting. And then in order to get rid of that, move it to the other side, I'm going to add 18 to both sides. So I'd have n is greater than, now I have to do negative 5 plus 18. That's the same as 18 minus 5. Right? Addition is commutative, which means I can move it around, and it's still the same thing. So 18 minus 5 is 13. And we didn't have to draw that one, but it wouldn't have been too hard if we did. Although I definitely do want to pick number 27 as being probably the biggest numbers on the page. We had a over 18 is less than or equal to negative 18. This is just one step, but it's big numbers. I've got to multiply both sides by 18 in order to cancel this out. So I end up with a is less than or equal to negative 18 times 18. I just got to work that out. 18 times 18. 8 times 8 is 64. And 8 times 10 is 80. All right, and then 110 times 8 is 80. 10 times 10 is 100. And now I just got to add all these numbers up. 400. There's 8 and 8 is 16. Plus 6 is 22. Carry the 2, 324. And it's negative. A is less than or equal to negative 324. Which seems like it might be a problem, but when we look at the graph that we're given, that's right in the middle of the number line that we've got there. So we've got negative 324, negative 326, negative 322. And I want everything that's less than or equal to that. So that will include that and then go left of. All right, I want to get into tonight's lesson because we're going to have a lot to get through. Maybe some new stuff for you, kind of start at the beginning and make sure that we've got the basics. So I'll give you a second, pull out your notes and get ready for that. I'm going to check, see if anybody else has logged in. All right, let's get started. We have been looking at number lines. That's how we're graphing our inequalities, where we have, there's one. To the left, well, in the center, we've got 0. And then to the left, we have negative numbers. Right, we have positive numbers. And what we're going to do today is we're going to add in a new axis, right? So instead of just this left-right line, we're going to add in an up-down line, right, through the middle of this. And we're going to count along it just the same, except as we go up, we'll go up. So this would be 1 and 2 and 3 and 4. Negative 1, negative 2, negative 3, negative 4. This is called coordinate plane, or some people hear it a lot, just kind of called a graph. Now, on this graph, we can display, instead of just like a dot being one number, we can have a dot represent 2 numbers at the same time. So let's say I've got this green dot, and it's, or sorry, blue dot, and it's over here. It's telling me 2 things at the same time because it's above the 3 and it's to the side of the 1. Now, the way we write this is first we have to name each of the lines that we're drawing on. So this is called x-axis. This is called the y-axis. All right. If you have drawn graphs before on an xy axis, send me a message and just say yes. If you have not, send me a message, just say no. I just want to know roughly if we've done these kinds of things before. And I'm going to explain real quick. So along the x-axis, the blue dot that I have drawn is above the 3. And so I'm going to name it with that 3. And it's across from, on the same level as the 1. So this point is 3 from this and 1 from that. All right, so this tells me 2 numbers about 1 point. And we are always going to name it with the x value and then the y value. So what this number means is it's right 3, up 1. Because if I start over here at 0, 0, because there's right 0, up 0. That's our center. We haven't moved at all if we're in the center. So if I start here and I move 1, 2, 3 to the right, and then up 1, I end up at the point 3, 1. in this, where both of these numbers are positive, we call this the quadrant 1, first quadrant. Now I could move left, and that's still going to be okay. So let's say I move left and up, and I've got a point over here. Well, for this one, all I did was I moved left 1, 2. So it's the x value is -2, and I moved up 2. So the y value is 2, right? It's along the same line as those two values. So this point is -2, 2, because we put the x value first, which was -2. Sorry, my handwriting wasn't great on that, -2 down there. And then we put the y value, which is 2. And this is quadrant 2. Don't know why we count them that way, but we do. We just started one place, and then we're going to rotate around. So down here in quadrant 3, I'm going to draw another point. So let's say I go left 4 and then down 3. So I go 1, 2, 3, 4. 1, 2, 3. So my point is going to end up right there. And that point is called -4, because that means left 4. And then the y value is -3, which means down 3. So I went left 4, down 3. So all these numbers do, these coordinates, the x and the y, they tell you where a point is. And that point, as we're going to see in a bit, sometimes represents a relationship between the x and the y. Right, and in my last coordinate, or my last quadrant, quadrant 4, I could have a point like this, right? And any of these points are fair game. So anywhere there's an intersection, and actually anywhere in between, we can have a set of coordinates. I'm just picking whole numbers for now because it's nice and easy. Okay, so this point here, I went right 2 and down 4. So I'll give you a second, see if you can write out the coordinates x first, and then the y coordinate. See if you can write the coordinates for that last point in quadrant 4. We always write them with parentheses and a comma in the middle. So we go right 2, 2, then down 1, 2, 3, 4. This is 2, -4. Now, on the homework, pretty much anytime you need to graph something, there will be a graph, a coordinate grid with the x and y axes, or x and y axes already drawn for you, and you are just going to have to put points or lines on there. You don't have to be neat for this. Although if you have graph paper, it's really nice for when you want to draw graphs like this. Okay. So if you want some practice, you can draw a coordinate grid, then graph, 5. And -3, 2, 1, -1, and 2, -4. I said draw a coordinating grid. Draw a coordinate grid. That's my bad. So if you want some practice, you can take those points, or you can take any points, or you can point somewhere and then find its coordinates. Right? I can just point here and then say, oh, that's 2, 3. I can just point over here. Oh, that's 1, -3. Or I can take points that I already have and put them onto the graph where they go. All right. Now, the interesting parts about graphs come when we start drawing lines on them. So when draw another graph, I get to cheat because mine draws straight lines every time. Five, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I've got my x-axis, I've got my y-axis. Now I'm just going to draw a line on this point, or on this graph. Let's draw it somewhere around here. I'm going to adjust it just a little bit. Okay. Now I could go through and find any number of points on this. So let's say I wanted to know, oh, what this point is. And we're going to pretend that all of these points that look like they're on an intersection are. So if it's just slightly off, that's okay. All right, so this first blue point, I could check and say, okay, well, it's 1, 2, 3 over 1, 2, 3, 4, 5. So it's 3, 5. And if I wanted to check this one, well, it's 1, 2, 3, 4 to the left, so -4, and then down 2. So this point was -4, -2. Now there are two particularly important points on this graph, and they are this one and this one. They're particularly important because they go across, they intersect the y-axis and the x-axis. So this one that intersects the y-axis, it's called the y, it's not intersect, but it's actually the intercept. Right? So it's intercepting with that line. This is the y-intercept. And the value of this point, well, it's not left or right. So its x value is 0. It didn't move right any, it didn't move left any. But it did go up 2. And then the other point intersects the x-axis. So that's called the x-intercept. And its value is, well, it went left 2, and it didn't go up or down. So it's -2, 0. Right, so we can use any 2 points. And if I get just 2 points and then I pull out a ruler and I'm really neat and careful, I can draw the rest of the line because lines are straight. That's just kind of the definition. So let's draw another grid. And let's pretend that we are given a problem that says to sketch a graph of a line with the x-intercept of 3, the y-intercept of -4. So with those 2 points, I can draw the line. Pick a different color. My x-intercept of 3 means that along the x-axis, I'm looking for the value 3. Right? So that would be, and they're all going to be labeled on the homework with all the numbers drawn out already. Right, so I'm looking for the value of 3 on the x-axis, and that's one of my points. And then I'm looking for the value -4 on the y-axis, and that will give me the other point. Right, so here's the y-axis. The value -4 is here. So this point is 3, 0, because it's to the right 3, and it's not up or down, right? It's on the 0 line. And then this point is -4, or pardon me, 0, -4. Right, and an x-intercept will always have a number, comma, 0. Like this, number, comma, 0, number, comma, 0. Y-intercept will always be 0 and a number, 0 and a number. Okay, now if I want to sketch the graph, I have enough. All I need is a ruler, and so you should have a ruler, and then I can draw a straight line between those 2 points. But I'm actually going to then extend that line through those points. Pretty much, you want to go to the edge of the graph you're given, and maybe even just kind of a tiny bit over, as long as you're like on the edge. You don't want to stop before you have to. And then I'm going to draw arrows on the end of this, just like I should have drawn arrows on all of these, right? And even on this graph over there, because the line just keeps on going forever and ever. I'm going to check real quick, see if anybody else has checked in. All right, good to go. All right, so that is one way to sketch a line, right? We can draw, we can graph by using intercepts. And all we need are those 2 points and a straight edge, a ruler, so that we can draw the line in between them. All right, but there are different ways to describe this line. I want to look back at this one. I'm going to plot a few more points here, or write them out. Right, so when I'm looking at these points, I should hopefully begin to see a pattern where this is 1, I had 0, 1, 2, 3, and then on the y values I have 2, 3, 4, 5. Right, so I can see that as the x values are increasing, the y values are increasing just the same. And each y value is 2 more than the x value. Right? Each y value is the x value plus 2. Right? And this is how we're going to see formulas for lines written, where we have y equals x plus a number. But sometimes we're going to have x multiplied by a number as well. So let me show you how to graph if you're given an equation. So this will be graphing equations. So let's start with something similar. We'll have y equals x minus 3. Now the way to do this and make sure that you've gotten every point right would be to do an input-output table where our input is x, and then we're going to calculate x minus 3, and our output is y. And then given that, we can write the coordinate. Right, so if I wanted to do that for this, maybe I start with minus 3, minus 2, minus 1, 0, 1, 2, 3. So now I'm going to plug x in to the next column. So I'd have something like minus 3, minus 3. And I'm just going to solve from left to right. So negative 3 minus 3 is negative 6. So I know that one of the points where y is 3 less than x is negative 3, negative 6. And I can do the same here. Minus 2, minus 3, negative 5. So there's another point. Negative 1, minus 3. And hopefully we're seeing a pattern here as well. 0, minus 3, minus 3. And so I'm noticing that, of course, my x's are just increasing by 1 each time because I want to find each point that I can. And so are my y's. I went from negative 6 to negative 5 to negative 4, negative 3. So I'm pretty confident that my next one's going to be negative 2, and then negative 1, and then 0. And I could work that out. 1 minus 3 is negative 2. 2 minus 3 is negative 1. 3 minus 3 is 0. Now, there's still a couple of different things that we can see here. These 2 points have zeros in them. So those are intercepts. Right, so if I have 0, then a number, that's my y intercept. And if I have a number, then 0, that's my x intercept. So if I wanted to, I could just find where x is 0 and find where y is 0 and get those 2 points. Or I could do what I did here and plug in a bunch of points. I did 7 points and plot them all, and they're going to give me a straight line. So let's draw those on the graph. I want that to be a black line. There we go. Okay. So for negative 3, I had negative 6. 2, 3, 4, 5, 6. Didn't go far enough. And my x value is negative 3. And I need to come down 1, 2, 3, 4, 5, 6. Way down here. And then for -2, my x value or my y value is -5. 1, 2, 3, 4, 5. Way down here. And for -1, got 1, 2, 3, 4. Now again, hopefully you're seeing a pattern where you think, I think I get where this is going. Right. Once we see where the line is going, usually we can just continue it out. The problems happen when if I accidentally calculate this second one down here, and I might get a bit confused. Or if I've got a point here and a point here, but then another point here, I probably did some math wrong. And these should always be in a straight line, but that straight line can be really steep or it can be really flat. And we'll get to that in a minute. Okay, so I've definitely got enough points to connect the dots here. And then on the ends, I'm going to put my arrows. All right. Now, another way we can do this is just to take it point by point and just graph them as we go. So I'm going to step up a little bit. I'm going to say, what if we had minus or negative of x plus 1? Now, the easiest point to find will pretty much always be the y-intercept, because that's where x is 0. So if x is 0, I don't even need to do anything with it. If x is 0, then y would just be 1, because I'd have 0 plus 1. So my first point would be 0 and 1. Well, let's see what happens if I put in 1 for x. I'd have y equals the negative of 1 plus 1. Well, that would be 0. So I have another point here, because the x I put in was 1 and the y I got out was 0. Here, the x I put in was 0, the y I got out was 1. I'm going to check one more point before I commit. And I want to go left. I want to find out what happens if x is negative 1. Y equals negative of negative 1 plus 1. Well, these two negatives are going to make a positive, so I have y equals 1. Y is 2 for this graph. All right, I'm ready to draw a line. I'm going to cheat. Stretch that out. Okay. But you just grab a straight edge, and you would do the same. All right, I don't need to know this point to graph it, because the line is straight. And I don't need to know this point to graph it, because the line is straight. It's going to get there. So I only need to calculate 2. They have to be correct. So sometimes, usually, I'll check 3 points. And if all 3 of those are in a straight line, probably on the right track. Of course, we always can make mistakes. Let's do another example. I want to show you just a little bit more of how this works, because we're getting to what will be kind of the normal way that you're going to think about graphing lines for a little while. Let's go 2x plus 2. I'm going to draw a graph, some arrows. All right. So I'm going to plug in 0 for x. And I'm going to say, if x is 0, what's y? Well, y would be 2. That's all that's left. Okay. What if I put in 1? Well, this would be So I'd have the point 1. So go over 1 and then up 4. 1, 2, 3, 4. This one looks a little bit different than our last one. And depending on how big the graph is, if I've got room, I could check x equals 2. So 2 times 2 is 4, plus 2 is 6. So I'm going over 2 because x was 2, and then up 1, 2, 3, 4, 5, 6. Way up there. I'm going to plug in -1. What if I have y equals 2 times -1 plus 2? What will y equal in that case? Well, multiply, do my simplification, y is 0. So for x is -1, y is 0. Right, so when I was looking at these numbers, or these graphs up here, x didn't have a number in front of it, and it ended up having this really even stair-step pattern, where it's up 1 over 1, up 1 over 1, up 1 over 1. Right, and that's what we call its slope. But here, now I've got this 2, everything is steeper. You draw this line. It's going up 2 over 1, up 2 over 1. Right, that is called the slope. And that number can be found here in the number that multiplies x. Right, so each time I move over and add 1x, I actually add 2 to my y value. And if I move 1, I add 2 to my y value. So again, this term is called slope. Right? It's describing how steep a line is. And we can use the slope to graph the line if we don't want to just plug in a bunch of numbers or connect dots. We can use the slope to just keep finding the next point on our line, which is really nice. Makes things go really quickly. Slope, how steep a line, is calculated by what's called rise over run. Right, so if I'm looking at this point, to get to the next point, the next intersection point, I had to go up 2 and over 1. So that up 2 is how much we had to rise, and then that over 1 is how far we had to run. And it won't always be the next x value. So we could end up with a fraction as a slope. I think most of the ones that we have right now, well, some of them are going to have fractions, yeah. So we'll do one of those here. So if I wanted to calculate, if I didn't already know the slope, I would take 2 over 1. Now, the letter we use for slope is m. Don't know why, it just is. So m is 2. Right, and then there's another nice thing that's popped up in our equation, and it's that this 2 is the value of the y-intercept. Right, so when we had x minus 3, that 3 was the value of the y-intercept. And when we had negative x plus 1, that value was the value of the y-intercept. That is why when you see an equation that looks like this, or what's called the general form, is this. And this m, again, stands for the slope, and b stands for y-intercept. Right. This is called slope-intercept form because it has the slope and it has the y-intercept. And when we have something in slope-intercept form, it's really nice because the y-intercept is in here. That gives us 1 point. The slope lets us just count over to the next point. And once we have 2 points, we can actually sketch the whole line. Now I want to point out one more thing before we do some examples. And that is that when the slope is negative, the line goes down and to the right. Right. And when the slope was positive, so there was a positive 1 here, the slope is up and to the right. Right, so this slope this was a positive 2, and so it went up 2 and to the right 1. I'm going to draw one more graph on here before I draw a new graph. So I'm going to write a new equation. I'm going to use green. Y equals -1/3. Right, so we're going to have fractions, x minus 2. All right, so we have a point because we were given the y-intercept. Right? If x is 0, I don't have to calculate anything, and I know that y will be -2. So I have 1 point here. And then to find my next point, I can use the slope to just count over to the next point. So here, my rise is -1. Oh, pardon me, bumped it. My rise is -1, and then my run is +3. So I'm going to go down 1, and then 1, 2, 3. And my next point will land right there. Now, these negatives, this negative could be out front, and it could be in the denominator. And those are all the exact same thing, right? -1/3 is -1/3 is 1/3. Those are all the same thing. If I think about it this way, with the negative in the denominator, that can actually move me backwards to the left to find more points. Because now it looks like my run is +1, so I would go up 1, but my rise is -1, but my run is -3. So that would have to move me left 3. So my next point would be way over here. Right, and we can see, oh, all 3 of these, they're following the same stair-step pattern, right? Over 3, down 1, over 3, down 1, and I could keep going. But I wrote slope-intercept form, so I can't go too far. But as long as I've got enough points to be confident, which is probably 3, maybe 4, then I can draw a line that goes through all of those points. And then draw arrows at the end of that. All right, so that's how we're going to draw just lines. Now there are 2 special types of lines that I'll make note of. We could have a line that says something like y equals 3. There's no x. And really, the x in this case just doesn't matter. So I would draw my graph, and I'm just like, okay, where does a point have a y value of 3? Well, This point has a y value of 3. It's 0, 3. This point has a y value of 3. It's 1, 3. This point has a y value of 3. It's 4, 3. I can go over to the left. This one's negative 4, 3. All right, so when we see something like just y equals a number, that is a horizontal line at the value. Right, so this is y equals 3. So it's just a horizontal line through 3. The other kind of weird line would be x equals 3. And I just happen to pick 3. Could be any number. Well, if I want x to equal 3, well, that's over here, because this is 3, 0. This is 3, 1. This is 3, 2. This is 3, 3. Down here is 3, negative 3. Well, that's just going to end up being a vertical line through that value. So y equals, if y equals a number, that's a horizontal. And if x equals a number, that's a vertical line. I think I have just enough time to show you just a little bit more. I'm just going to make it kind of simple. Just going to use y equals x as my line, so we don't have to do a whole lot of math. So y equals x can look like this, right? What if I wanted not just the y's that are x, but y's that are greater than or equal to x? Right, so this would be 1, 1, and 1 is greater than or equal to 1. Right? And this point down here would be negative 2, negative 2, and negative 2 is greater than or equal to negative 2. Right? These are both equal to. But what about that greater than? What if I took, I don't know, this point? Negative 1, 1. Okay, so is 1 greater than or equal to negative 1? It is. Let me look at this point over here, 2, negative 2. Is negative 2 greater than or equal to 2? That one's not. So I could go through, I could test this point, and 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 that point. And all of these points, the y value is greater than the x value. But instead of drawing every point, because there are too many, we shade above that line. So if we have y is greater than or equal to a line, we draw the line and then shade above. Well, what if instead I wanted y is less than or equal to some line? It's basically the same, except I don't want all the numbers that are greater than the line. I want all the numbers that are less than the line. So this would be draw the line, shade below. So in that case, if I had y is less than or equal to x, I'm just going to use green, I would shade over on this side. Right, and you're just going to be, you can use highlighters if you want, or your pencil, just give a nice even shade. Don't like draw lines, try to make it shading. I'll just give you the last rule for these problems. because we did equal to, we've done greater than or equal to, we've done less than. If we wanted to do y is greater than x or y is less than x, and I'll just do these two as examples. I'm just doing quick sketches. Now remember when we did like x is greater than, we did an open circle, right, to show that it's not equal to that circle. It doesn't equal that point. For a value, or for a graph like this, we're going to use a dashed line instead of a solid line to show that it's not equal to that line. And then shade above. I got a little bit below on that one. Okay, and if I wanted y is less than x, I would graph y is x, but dotted, because y doesn't equal x. Y is just the things less than x. And then I would shade below, right? Because greater than is above, less than is below. And then the only difference is, or the different cases, if I had x is greater than or equal to 3. So if I wanted to change it to that, well, x increases not up, but to the right. So for something like that, I would shade to the right of that value. There should be, there's like one problem like that on the homework, and hopefully that made sense. Mr. Castro can catch you up on anything I missed. Hope you guys have a wonderful night. Thank you.